Our group will be presenting about pre-stress losses in pre-stressed concrete, focusing on both short-term and long-term losses. Pre-stress loss refers to the reduction of the initial pre-stressing force that occurs over time. In other words, it's the difference between the initial stress applied to the tendons and the effective stress that remains later on. These losses can occur in both pre-tensioning and post-tensioning system. They are important because they affect the strength, serviceability, and durability of the concrete structure. Generally, pre-stress are divided into two categories: immediate or short-term losses such as elastic shortening, encouraged slip, and friction; time-dependent or long-term losses which include creep, shrinkage, and relaxation. Understand these losses helps engineer ensure that the final pre-stress level in the concrete remains effective throughout its lifespan. Elastic shortening happens right after the pre-stress is transferred from the steel tendons to the concrete. When this happens, the concrete compresses and shortens, and because the tendons are bonded to it, they also shorten. This results in the reduction of pre-stress in the steel. In pre-tension members, the tendons are tensioned before the concrete is poured and hardened. Once the concrete gains strength, the pre-stress is transferred, causing the concrete and tendons to shorten together. This leads to a full loss of pre-stress. In post-tensioning members, the tendons are tensioned after the concrete has already hardened. If all cables are stressed simultaneously, there is no loss due to elastic shortening. However, if they are stressed one after another, the tendons were tensioned earlier will lose some of their pre-stress when the other are pulled. This results in partial loss, usually around 50% of the pre-tension case. To summarize, elastic shortening is an instant and unavoidable loss that must be considered in pre-stressed concrete design. It's more significant in pre-tension systems and can be reduced by simultaneous stressing or by careful tensioning sequence. Understanding and controlling this loss helps ensure better performance and long-term durability of pre-stressed structures.
Now I'll be explaining about friction loss in pre-stressed concrete. Friction loss happens due to the resistance between the pre-stressing tendon and its surrounding duct surface during stressing. In simple words, as the tendon is pulled and stretched, some of the tension is lost because of the friction between steel wire and duct. For example, if we stress a tendon that passes through a curved duct, the friction between the duct and the steel reduces the effective pre-stressing force toward the far end. This means that the farther we go from the jacking end, the smaller the effective pre-stress becomes. One of the main causes of the friction loss is the unintentional curve, which is caused by small irregularities or wobbling in the duct alignment. The table shows the coefficient of friction of post-tension internal tendons and external tendons. Loss due to friction can be estimated from the equation of 5.45, where the theta is the sum of the angular displacement over a distance x, mu is the coefficient of friction between the tendon and its duct, k is an unintentional angular displacement for internal tendons, and lastly x is the distance along the tendon to the point where the pre-stressing force is equal to P max. In conclusion, friction loss is an important factor in pre-stressed concrete design because it directly affects the efficiency of the pre-stressing force. By understanding and controlling friction loss, we can ensure the structure performance and safety of the pre-stressed member.
Next, I will explain one of the pre-stress loss in concrete, which is the immediate loss due to anchorage slip. When the steel tendons are stretched and anchored, a small slip can happen at the anchorage when the force is transferred from the jack. This tiny movement causes the tendon to shorten slightly, it reducing the overall pre-stressing force in the beam. Even a small slip, like 2 mm, can cause a big reduction in pre-stress, especially in short beams. That's why this type of loss is called an immediate loss. It happens right after the tensioning process. To control this, engineers often overstretch the tendon slightly or use better quality anchorage system that grip the steel firmly. In short, anchorage slip may seem minor, but it's an important factor that affects the beam strength and performance.
Next is losses due to creep. Creep means the gradual deformation of concrete when it is subjected to a constant sustained stress over time. In simple words, when a concrete member is loaded continuously, it slowly stretches or compresses over time. When the concrete creeps, it shortens slightly under the sustained compressive stress caused by pre-stressing. Since the steel is bonded to the concrete, the tendon will also shorten slightly, causing a loss of pre-stressing force. This is called loss due to creep of concrete. Loss of stress due to creep of concrete can be calculated using this formula: modulus elasticity of steel times by stress in concrete times by specific creep strain. Modulus elasticity of steel range between 200 kN per mm square to 210 kN per mm square. Stress in concrete can be calculated using this formula, which is remaining pre-stress force divided by cross-sectional area of the concrete times by 1 plus eccentricity squared times cross-sectional area of the concrete divided by moment of inertia, while specific creep strain can be calculated using this formula, which is creep coefficient divided by 1.05 times modulus elasticity of concrete.
For the next, long-term losses will be shrinkage. It's a time-dependent loss occurs due to the shrinkage of concrete over time. As concrete shrinks, the structure shortens slightly, reducing the tension forces in the prestressing tendon. The factors likely affecting the shrinkage loss is the loss of moisture and chemical changes during the cement hydrations. To reduce the shrinkage effect of large area structure is by constructing a construction joint to reduce the shrinkage effect and ensure the stability of the structure. For relaxation, loss is the reduction in stress within the pre-stressing steel itself over time, while the strain length of the steel is kept constant. The factors affecting will be the microstructural changes in the steel under long-term high stress, temperature effects, and quality and type of pre-stressing steel. The effects to the pre-stress will be decreases gradually in time of the pre-stressing forces, and the concrete stress correspondingly reduces. That's all from our group. Thank you.